So I think we'll make a start. First of all, welcome everybody to our introduction to Astro-imaging Part 1. It wasn't how we intended this to be given. We intended to have a room with everybody together and a lot of interaction, but needs as needs must. So we decided to split this into a number of parts and do them in this virtual world. Before we start, I'll just have to say a little bit about the Astronomical Society. Can you change the slide, Mark? Thanks. For anybody who joins us on YouTube, the Astronomical Society of Edinburgh was founded in 1924, so we've been going a long time now, and we're a thriving group with over 100 members. And normally we'd hold our meetings on the first Friday of the month. In fact, next Friday we will be having a meeting in this virtual world when Professor Giles Hammond of Glasgow University will be talking about longitude and clocks. Also, the first Wednesday of the month, we have an imaging group meeting, which is for members only. And again, that will be a virtual meeting. For anybody who's interested in joining, it's incredibly good value, £30 a year. Or if you're old or young in full-time education, only 15. And all those details you can find on our website. Thanks, Mark. So, tonight, you've got the benefit of myself and Mark. Now, Mark is the go-to man when it comes to imaging, always striving for that last 5%, whereas I take a slightly different approach, an 80-20 man. So I'll put in 20% of the effort and be quite happy with 80% of the reward, and also get a lot more images. But that's a balance that Mark and I argue about a fair bit. We're going to concentrate on wide field imaging with a camera and tripod, mobile phone imaging, and imaging through a static telescope using a DSLR. We'll take questions at the end and then we'll tell you what we're going to do next. Now, this introduction to astro-imaging is the fourth part of our 4 steps program, which we introduced, what must be about 18 months ago now. Buying a telescope is an online article that we first put up probably before Christmas 2018 and revised 2019, and goes through the pros and cons of what you should be looking at when you're buying a telescope. We've now run 2 telescope help shops, which have been both oversubscribed, where people have brought their telescopes that have been lying in cupboards somewhere or recent acquisitions, and help people set those up and understand how to get the best out of them. In February of this year, Alan Pickup ran our Navigating the Night Sky, which is an introduction to finding your way around the night sky. Again, very well attended. And tonight is, as I said, the fourth part of that process, but we're going to have to split it into a number of parts. We suspect it to be about a half-hour's session tonight. Okay, Mark.
Could we mention that we're going to gather any questions on the chat page? So that
yes, certainly do that. Anybody who has any questions and wants to post them on the chat line at the bottom, we can take those at the end. If we're pressed for time, Peter can go through them and highlight the ones that and get people to ask them. But if you'd wait for him to sort of indicate when we want them, that would be very useful. If we just have open mics, it might just get a bit crowded here. Thanks, Peter.
Okay, just a few intro remarks from me. I I think Andrew and I would both happily say there are much, much better images out there than we are, and people who know an awful lot more about imaging than we do. But what we're sharing with you, our experiences, what we do, we take pretty decent photographs. So it might be very introductory. There's a limit to what we can do here, but if you really do want to get into imaging, then I would encourage you to join the society and join our imaging group, because we do go through a lot of stuff in detail there. Lots of detail on how to capture the data, but also how to process it using bucket loads of different software as there is. So that is the next step if you want to take it further, really. Some basics. Fundamental fact: the Earth rotates, and therefore the stars appear to move from east to west. I hope you all know that. So as you can see in the picture, stars will trail if you take long exposures. So if we don't want stars to trail, we have to track the stars, or we take exposures so short that the stars don't trail. Sometimes we do actually love star trails, especially around the pole. Those are very attractive. But for this session, we're talking about short exposures and avoiding the stars actually trailing. So it is the basic part of imaging tonight. We will go into more complex stuff in later sessions. We'll go all the way through to full narrowband imaging if you wanted to do that, but we'll start here. And I think it's back to you again, Andrew.
Thank you. Okay, I'll talk first about a fixed camera on a tripod. There's my my trusty DSLR. It's not modified in any way. I take lots of different pictures in a more normal manner rather than at night. So it's not been modified. I've just run through the typical settings that I'd use for a dark sky image. So the first thing to do is to make sure we've got the camera set to manual mode, and then we adjust the aperture, the ISO, the sensitivity if you like, and the exposure, and most importantly focus. Trying to do some of these things automatically is fraught, so you're much better making sure you have control, and then you can adjust them to improve the results or see what effect it gets. A remote cable is useful, or a remote release. I have a wireless remote, but I more often than not use the self-timer on the camera. This avoids any camera shake, gives it time just to settle down and take your image. I guess the other thing I ought to say, it's also quite useful to make sure the camera is at the sort of ambient temperature. Taking a camera out your warm house or a warm car and putting it out in a cold night, not only is it like to fog the lens up, but you can get warm air currents around the camera and causing some distortion. So making sure you've got the kit ready and cool to use is the first step. Can we go to the next slide, Mark? Now, aperture. We want to get as much light as we can into the camera. There's precious little out there for us to use, so to maximize it, we want as wide an aperture as we can. But sadly, some cheaper lenses can cause some softness, particularly around the edges of the image. Mark's top tip, if you've got one of those, and I guess the only way you'll find out is by trying it at its fullest aperture, and then try stopping it down 1 or 2 stops. Now, you'll get slightly less light, and it will be a trade-off. In theory, I suppose you could crop the image afterwards if it was a bit soft around the edges. The other thing to adjust we mentioned before is the ISO or gain. Each camera has its optimum ISO. The Canon 600D around 800, the 700D around 1600. Now, there are trade-offs, and you have to decide which of the trade-offs suit you, but it's better not to go too high and get a really grainy image. But you want it high enough to be able to actually see something. So you can have a look online and just have a look what the ISO is for your particular camera. I tend to use mine when I'm doing dark skies around the 2000 or 2500. Thanks, Mark. So what exposure do you use? We've said we want to gather as much light as possible, but without trailing. So if it's too short and we avoid the trailing, we won't get a decent image. If it's too long, we trail. So there's a rule of thumb, the rule of 500, which gives an idea of how long you can expose the stars without trailing for any given focal length. But it is a rule of thumb, and again, it's a trial and error. So the rule of 500, if the exposure is equal to 500 divided by the focal length and then divided by the crop factor, and there's some crop factors there for the Canon and a Nikon. So for a 50mm Canon lens, it's 6 seconds. For a 24mm Nikon lens, 14. And there's a table. These slides we can make available on the website, and but you can find them on the internet. And it's a useful guide. I use probably 18mm lens on my Nikon. I tend to use 30 seconds, and I get a little star trailing. But the trade-off for me, I usually find is reasonable. Thank you, Mark.
Sorry, I had to deal with a child.
File format, always shoot in RAW. You keep all the data, JPEG, you do lose data. And once you've lost it, you won't get it back. This is a picture of the back of my camera. I actually shoot in RAW and JPEG. So it saves the file in both formats. That way I can quickly look at the image on the back of the camera and get a reasonable idea of what it might look like. So it just helps in that respect. Now focusing, focus the lens manually. We put autofocus really works for stars. The 3 images I think I've got at the end of this little piece were all taken, and I use autofocus. With mine, I find if I press the shutter half down to focus twice, it works. If I do it once, it doesn't. But
Never had that work for me, Andrew. Never had that work for me.
Well, it does, and as long as it does, that's fine. But it may be that you need to focus before the session and mark the lens or tape the lens. I've seen people do a variety of things to make sure that they get focus. And let's face it, it's not worth taking the picture if you've not got it focused. Using live view also helps to just sharpen up, and you can zoom in on some images using live view to manually adjust if you need to, particularly if you're taking things like the moon rather than star pictures. So they're the basic routines I would go through for using this sort of format. And I think I've just got 3 images. I mean, that's one I took at Calendar. So it's, in fact, I think all these 3 were at Calendar. A good dark sky. You'll see just center right. You can just pick out Andromeda and the Milky Way. And these were all taken f4, 25 seconds, ISO 2000. And just another one of the Milky Way. And putting a few trees around it at least gives it a bit of a frame in terms of reference, which is quite useful. and the sun had not fully set on Lake Veneca, but I snapped it anyway. So it just gives an idea that by no means exceptional images, but it just shows you that if I can do it, anybody can do it and get reasonable results. Thanks, Mark.
Oh, the next thing we're going to discuss is about using your mobile phone on a telescope. I think both Andrew and I would admit we haven't done a huge amount of this, but a lot of people have, and some people have got incredibly good results. At its simplest, if you've got a steady hand, hold your phone to the eyepiece of your telescope, try and get the moon in focus, for example, take an image, but it really isn't easy. Better yet, get a simple holder like this off eBay. It's about 10 quid. You can get a really fancy one like Peter's got, which costs you about 4 times that, I think. And it is a lot better. It gives you a lot more fine movements and fine adjustment. But I find this one is very easy to get your camera aligned really well. And it is £10 or less. So you attach it to the eyepiece like that. You stick your phone on it and align it to the lens of the eyepiece, and you take an image. Better yet would be to use manual settings for your phone camera as well, which you can do. Even better, if you're up to it, is to do videos with it, and then you can do full lunar and planetary imaging, as some people have actually done. I haven't managed anything close to that, but we will cover how to process lunar and planetary videos into nicer, sharper images in a future session. But it really is lots of trial and error with a mobile phone, so I'll give it a shot. Try it out, but it is quite good fun. I've managed a couple of pictures. I can't actually find them, which is why I haven't put them on here, but there are some amazing pictures taken with mobile phones on the internet. That's all we'll say about mobile phones. Any one of you want to lead the way on that in the society, please do so, and then give us a talk about it later on. The next thing is getting more towards using telescopes and cameras together. So a DSLR camera through a telescope with just a single shot, a single short shot, so that we don't have to track the stars in this case. What you need a camera with the lens taken out. You need something called a T-ring, which fits your specific camera. So you might need one for a Nikon or a Canon or whatever your brand is. And then a standard T adapter, and that connects your camera to the telescope. The attachment to the telescope can be one of a number of ways: straight into the 1 1/4 inch draw tube, or a 2 inch draw tube, or even to a T-thread itself. It's very hard to say what you will actually need for your kit, because there are so many different ways of connecting it up. And recently there are different sizes of T connectors as well. So you used to get a T, which was a small size. Now you get a T2, and then you get M48s and all sorts of other connections now. Unfortunately, it can be a bit of trial and error, which means you might end up buying the wrong extension for your camera. But for most cases, it's fairly straightforward. You need a T adapter and a T-ring.
And I think that's probably one of the advantages of being at a club like ours, because I think it's fair to say most people will let you borrow one for a short time if they've got a spare, and you can try it.
And I've made so many mistakes. I've got most of the different sorts of adapters going, I think. So I'll certainly have something for you. DSLRs often need a bit more back focus. Sorry, that's the connector to the T-ring in the camera. That's it plugged into the camera, into the telescope draw tube. That's just plugged in with a 2 inch adapter to the 2 inch draw tube. But DSLRs sometimes need an extra bit of back focus. So you might find you can't actually reach focus with your telescope normally. So you might need an extension tube to stretch it out even longer. And I think a lot of people do get that problem when you first connect a telescope to a camera, that they can't actually focus it. As Andrew said before, a shutter release is very useful. Really, you want to reduce the vibration from the mirror. You can do it in other ways. You can go into live view mode, which locks the mirror up for you in the first place. If you have a fold-out LCD screen on your camera, that makes life so much easier because you don't have to bend over at an awkward angle to see the screen to focus on it. If you're thinking about buying a DSLR to do something like this, pick one with a fold-out screen. It's certainly worth it. There are other ways of doing that. You can connect your camera live to your laptop with the software that comes with your camera and do a live view on there, and that can make it easier to focus as well. But focusing, as Andrew said, is a key thing. So some techniques. Point the telescope at the object. It needs to be something bright, so we're doing short exposures here, so the moon or the sun with a suitable filter, not the filters that come with the cheap telescopes that go in the eyepiece, but one that goes over the front of the telescope. Otherwise, you will damage something, probably your eye or the camera. So it needs to be a very bright object here. We're focusing the telescope using the live view on the LCD screen and zoom in as far as you can to get it sharp. You then try in various exposures and to get the best image you can. And high ISO isn't required here, so you can use a really low ISO setting. Very important not to overexpose it. If you overexpose it and you blow out some of the region so it's just pure white, you're not going to get that back. If you underexpose it a little, you can bring some of that out later on. There's always a chance of bringing that back with image processing later on, but once it's blown out, you won't get that back. You just get white there. There's an unprocessed image using that very technique, using the telescope and camera sitting behind me there. No processing done at that one. And the top tip, if it's not in focus, don't bother. I've done so many sessions where I thought it was in focus. I thought it's close enough, I'll try it out. Done 3 hours of imaging, and next day processed it and realized that it was so soft and fuzzy that it was a load of rubbish. So get the focus right, check it again. And if you're doing a long session, check it again several times through the night, because as the temperature changes, the focus can change as well. But my top tip, don't bother if it's not in focus, you'll waste your time. Okay, this is where it all goes wrong, potentially. I'm going to do a live processing on that processed moon image you just saw there. So I'm going to share a different screen now, I hope. Okay, so what I'm actually using here is Lightroom. I use a variety of tools, Lightroom or Photoshop and some other things as well. But in this case, for a single shot, Lightroom's quite a good way of doing it. If you're a photographer, you may have used this already. It's very, very commonly used. It costs money, but in some ways it's definitely worth it. So I'll just do a few simple controls to see what we can get out of this. If you look at the raw image itself, it's pretty well focused. It's not too bad. Because it's a single shot, you can't zoom in too much without getting a lot of pixelation and noise, but that's for a single shot image, that's pretty good. So I'm just going to crop this in so we can see the image a bit closer. Well, there we go. Okay, so the sort of things we can do, it's slightly brown. I prefer my pictures to be slightly bluer, but that's what the camera has done. If I pick this thing here, setting the white balance, I can pick a neutral bit, slightly bluer. We can adjust the controls there. Color in astronomy is in the eye of the beholder, so you make your color what works for you, really, I think. Your eye responds to it in a different way from the sensor, from other people's sensors, from other people's eyes anyway, so make it look attractive to you. It's quite a sharp image as it is, but we can do a lot of stuff in Lightroom controls, such as clarity and texture as well. I'll zoom a little bit on that. If you do too much, then you'll start to get pixelation and noise and so on as well, but these simple controls in Lightroom can make a big difference. Sometimes you can actually get variations in color on the surface itself that show up the different minerals, I suppose. Sometimes it comes out, sometimes it doesn't. Sometimes it's just color in the atmosphere, I think you're actually picking up rather than on the moon itself. There are various features in Lightroom, such as curves here. So I quite like to bring out the highlights on the moon. So if we look over here, this impact crater here with the rays coming out of it, that's really nice and white and bright, or you can turn it right down, but I think they stand out really nicely if you do that. You can increase the different areas, the lights, the darks, and then if we want a bit more shadow, we can do that. But if we get the black too far down, we start losing the Terminator itself. But as you can see, it's already starting to be quite a nice image from just a single shot. Right, bump the clarity up, you can see a lot of change there. But if I was to zoom in on that, it's pretty horrible underneath, and the black areas are actually starting to get noise as well. So with image processing, it really is about balancing all the different sliders until you get something that looks good, isn't too noisy, and is pretty satisfying. I think a bit of contrast there, make a difference. I think maybe hopefully that's going to work. There you go, that's the image. Slightly noisy, but not too bad. We can actually get rid of some of that noise as well in here. I think there's a smoothing option, detail here. So we could sharpen it a bit more if we wanted to. I don't think we need to sharpen that anymore, but you can make a horrible mess of it by sharpening that. Or we can reduce the noise a little bit, get rid of some of the grain. And that fundamentally is how I would do image processing of a single app, and you get something pretty quickly that looks quite decent. Okay, I'll go back to the previous slide.
Something that's quick and simple appeals to me.
Right. Okay, so that was a quick example of processing a single shot moon image. And there's really nothing special about that. I think it probably took me about 5 minutes to take that image. I had the telescope set up in the lounge. I saw a clear patch in the sky and saw the moon, took it outside, pointed it, focused very quickly, tried a couple of shots, brought it back inside, and it was done in no time. And then the processing, once you're used to doing it, can take 5 minutes as well when you've got a nice picture. So that was the image we started with. It was reasonably nice in the first place, and that was approximately the image we ended up with. There's more contrast. You can bring out more details, including the ray craters and so on. But if you go too heavy-handed on your processing, then zooming in, you'll see there's a lot of noise, a lot of pixelation, and not particularly pleasant. Yes, another tip that I've learned the hard way: do your image processing in a darkened or a dim room. So I've done a nighttime session, got up in the morning in the bright sunlight and think I need to process this, uploaded it online to the website, and later on in the evening when it's a bit dark, I realized, how did I ever put that up? It's a disgusting image with pixelation and noise and all sorts of strange colors. So it does actually make a difference doing it in a slightly darkened room. Bright enough so you can actually see the keyboard, but darker certainly makes a big difference to me. Maybe it's my eyesight. Software for processing these sorts of images. Adobe Lightroom we just saw, Adobe Photoshop I use as well. Those two obviously are not free. I think you can get an annual subscription that for about under £100 that will get you both of those, but it's an annual subscription, so it's not cheap at all. GIMP, which some people use, I haven't got a huge amount of experience with that, and that is free. You can do a lot of the stuff you can in Photoshop. You do it slightly differently, but there are lots of tutorials online that will show you how to do that. Registax is a program that I use. It's not normally for this sort of imaging. It's normally for video imaging, high-speed video of the moon and the planets and the sun. But it has some features in there, such as the wavelets, which are very useful for sharpening your lunar images, and you can do one or two other things as well, such as contrast and brightness and color correction and so on. So it's quite useful for some things.
Yeah.
But another slight tip, you spent a lot of money buying a telescope and your imaging kit, probably. So don't neglect your software. Sometimes it's worth buying a bit of software. Just consider that as being part of your imaging budget. If you can bear it, it feels a bit intangible, a piece of software that you should be paying for it. But as a former software developer, I can tell you, you need to buy software. It's good. And I think that was our little presentation tonight. What we will do over the next day or two, we will upload some sample images, some raw images that you can actually work with yourselves. You can download some of the free software and give it a shot yourself. We'll put some single wide angle shots like you saw of Andrew's. I'll put some moon and sun images up there. And there are links to software on our website, on the Astronomy links page, so you can find a way to download this software from. Yeah. But the best way to get into it is to just try it out, and these images are a good way of doing it, really.
Sure.
Very good. We have a question. Christopher, would you like to unmute your microphone and ask your question?
Yes. Hi, everybody. I've always been interested in photography. I've got a camera, dabbled around a wee bit, but it's not something I've really picked up, but I'd like to get into it more. In terms of software, there's so many different kinds out there. It's a wee bit overwhelming, so to say. Lightroom, I've heard a lot about of, but I'm unsure of what you can actually do with it. I've heard stacking images can help bring out a lot of detail. So I'm just wondering if Lightroom can be used to stack images.
No, it can't. We will do stacking in one of the next, in fact, the next session we probably will cover stacking. Lightroom won't do stacking for you. You can do a bit of stacking in Photoshop, but it's not the tool you would use for that. There's a free tool called Deep Sky Stacker, which is exactly for that purpose. You'll find a link on our website for that. There is another new piece of software out called Cyril, S-I-R-I-L, which is very new actually, and it's looking like going to be a very good piece of software, and that's free as well. So these will be the tools you would use for stacking your images. There are others as well, such as Nebulosity, PixInsight. These all cost money, but both Cyril and Deep Sky Stacker are good enough that you don't need to spend money on the stacking side of it if you don't want to. But stacking will make a huge difference to your images. If I'd stacked 10 images of the moon there that I did like that, the noise would be much less. It would be a much smoother and sharper image you could get out of that. But we will go through stacking in one of the future sessions. We'll discuss a little bit about the theory behind it, just so you understand what it's about. But yeah, good question.
Do we have any other questions? If so, can you just unmute your microphone and ask away? I guess it was a brilliant presentation.
That's what I like, a comprehensive, coverage. Right, so as Mark has mentioned, part 2 will be covering the next sets of areas. So using a telescope, a guided telescope mount that actually follows the stars, follows the objects, longer exposures. I get the impression that some people almost go to bed and get up, turn in on the exposure before they go to bed and then turn it off when they get up. Stacking and the sort of technique I use, which is electronically assisted astronomy. It certainly makes things easier for me. Okay, well, I think that's everything covered from the point of view of this this particular session. Thank you very much for joining. Don't forget on Friday night at 7:30, We have Giles Hammond. And the following Wednesday at 7:30, we have the imaging group. I look forward to seeing you all then. Thank you.